Lily, thank you so much for the chocolates.
It's time for Maths with Mr. Thomas.
We have made it to the end of the statistics chapter. Woo! Let me hear you. Woo! This is the review lesson. It is just me going over all the key points. I will just go over everything that you need from all the lessons. I'll show you just a quick example, but I won't go over anything in great detail and I won't show you all the examples. If you want that, look back to the individual lessons. I would just use this just to make sure that you know everything from the chapter if you're wanting just a quick recap of what it involves. But we started this statistics chapter by a recap of the mean, the median, the mode, and the range. Just remember, how do you get the mean? You add the numbers up and you divide by how many you have. You do indeed, yes, the total. Then divide that by the number of numbers that you have. So for example, three melons weigh a total of 6 kilograms. To get the mean weight, well, the total is 6, and there are 3 melons, so it's a 6 divided by the 3. That is how you get the mean. If, for example, here you're wanting the shoe sizes of 6 people, well, again, you get the mean by adding all the numbers together and then dividing by how many numbers you have. So the mean is the total divided by how many numbers you have. The mode, what is the mode?
That's the number that appears the most.
It is, but it doesn't have to be the number. It could also be a flavour of crisps, for example. If you ask people their favourite flavour, if more people said ready salted than anything else, then ready salted would be the mode. But it is the number or the value, the name, the whatever that appears the most. So in here, Shep compared the price of a glass toaster in 5 different online shops. The mode is just the number that appears the most. There's the 33 there, there's another 33. The 33 is appearing twice, all the other numbers just appear once, so 33 is the mode. The median, what is the median?
That's the middle value when you put all the numbers in order.
Perfectly right, yeah. The way I remember it is thinking about small, medium, large. Medium sounds a bit like median. It's the middle value. So you put the numbers in order from smallest to largest and you take the number that is in the middle. Just remember, you do have to put the numbers in order first of all. So these numbers here, they are not ordered. They're just all jumbled up. Higgery, piggery, pokery, pokery. So put them in order first of all, from smallest to biggest. In order to get the one in the middle, what you could always do is cross off one from the left and one from the right. One from the left and one from the right. One from the left and one from the right. And you see that there's 2 numbers in the middle. I'm sure you know by now what you do if you have 2 numbers in the middle. You take the value that's halfway between them. You do indeed, yes. You think what's halfway between 6 and 8? It is 7! So 7 would be the median. If it's a bit trickier to work out, if it was 6 and 382.4, well, the number that's between them is a little harder to figure out. So, in order to do it, to work out the median, you would add the 2 numbers together and then divide by 2, i.e. taking the mean of the middle 2. And the range, what is the range?
Well, that is a measure of the spread of the data.
Yeah, you're perfectly right. It shows you how spread out your results are, and the way you find it is by doing the biggest number. Take away the smallest. That will give you the range. For example, here, Liam took a note of how many minutes his bus was late by each day. Here's the results. Calculate the range. All you do is you find the biggest number, and you take away the smallest number. So there is a range there of the 10 minutes. Woo! Quick summary. The mean is the total divided by how many numbers you have. Stupid ways that I remember it. Calissa, if I said you were mean, well, it's not very nice. And it's not nice when you've got to add all the numbers together to get a big total. And then what do you have to do? Divide. No one likes dividing, so it's adding them up and then dividing. That's how I remember it. If it's the mode, I think about the 2 letters M-O. That's the number that appears the most. So MO for mode, MO for most, they start with the first 2 letters. Or you could think MO for that number that appears the most often. Median, I said that's just like the middle number because it's just like small, medium, large. And medium sounds like median, slightly. And for the range, I just remember that if you've got your own way. Brilliant! Let me know what it is. But just think it's the biggest number, take away the smallest. That was lesson 1. After that, we went on to look at quartiles. Ba-ba-ba-bam! What are quartiles? Well, that was when you split your list of ordered number into 4 equal parts. And the way you do it is you find the median value. That would split your list of numbers into 2 equal parts. And then what you do is you take the lower part and the upper part and you find the median of them. After you find the lower median and the upper median, they are known as quartiles because they have quartered the group. You've got 2 numbers, 2 numbers, 2 numbers, 2 numbers, so it splits it into the 4 sets of 2 numbers. It's 4 equal sets. And you've got your lower quartile, your median, and your upper quartile, known as Q1, Q2, and Q3. If you had to do this example here, find the quartiles for this set of 11 numbers, well, again, just make sure that they are in order. They are in order, going from smallest to largest. Get your median value. You can do that by crossing off 1 from the left and 1 from the right. 1 from the left and 1 from the right, and so on. You'll get your middle value. After that, if you've circled this 7, that's the median, so we ignore that now. And we just look at these 5 numbers and take the middle for the lower quartile. Look at these 5 numbers at the top, and then take the middle of that for your upper quartile. And that's how you'd find your lower quartile, your median, and your upper quartile, or Q1, Q2, and Q3. If you've got 10 numbers, well, what you'll find is that the median is halfway between 2 numbers. And if the median is halfway between them, what do? You add them together and divide by 2. You do indeed. So you would add the 6 and 10, half that, and you get 8. Or sometimes it's dead easy. You know what's halfway between 6 and 10. It's 8. We know that, so that is your median. And because we have not included either of those numbers, this is the number that's halfway between them, well, we're still looking at the 6. The other 6, the 4, the 3, and the 1 for the lower part in order to get the lower quartile. And we'd have these 5 numbers here in order to get the upper quartile. It's the middle of them. Once we have found the quartiles, we can work out the interquartile range and the semi-interquartile range. Remember, what I was saying was, if you want to look at the spread of the data, the range is how you can work it out. But sometimes if you get what's known as outliers, well, that's going to make the range appear massive. It's going to make it appear a lot bigger than it actually is, like this example here. Again, I'm going over this in more detail if you look back to this individual lesson. But this 35 is what's known as an outlier. It's far bigger than any of the other numbers. I suppose 2 possibly you could say would be an outlier as well. It's a lot smaller. But these 2 numbers are putting this example out when you're looking at the range. What ignores any outliers and just looks at that middle 50% of the data is your interquartile range. And the way you find it is you use your quartiles. You do Q3, take away Q1. Or to get the semi-interquartile range, that is when you semi means half. It does indeed, yes. You just divide by 2. So it's Q3, take Q1, divide by 2. With this example here, we had to work out the median, the lower and upper quartiles. So Q1, Q2, Q3. And after we did that to get the semi-interquartile range, we did Q3, take away Q1, and then we divided by 2. Make sure you don't divide by Q2. It's 2 you divide by, not Q2, which is a common mistake. That is your semi-interquartile range. If it was just the interquartile range we wanted, then we wouldn't divide by 2. We would just work out Q3, take away Q1. After that, we went on to look at the standard deviation. Ba-ba-ba-bam! As it says here, the range and the interquartile range, or semi-interquartile range, are just based on 2 values, so they don't always give an accurate representation of how spread out or varied different results are. Something that's far better to use is the standard deviation. On the formula sheet, there are these 2 formulas. This one, though, on the right, I do not teach, so I did not go over that one at all. This is what I prefer to use for standard deviation, so this is what all of my examples use. In order to use either formula, you do have to know, though, that S is your standard deviation. N is the total number of pieces of data, so if you're looking at the standard deviation for the heights of 10 people, N is going to be 10, because you'll have 10 results. X is used to represent a single piece of data, which you'll see in the table on the next page. X bar is the mean, and sigma is the total. It's the sum of. These are used when it comes to the table that you have to copy out. To work out the mean and standard deviation, write down your numbers, take the mean away from each of the numbers, After you've got these here, you can always do a check. If you add them together, you should always get 0, unless your mean is rounded. If it's rounded, it'll be out slightly, so this will be out slightly from 0. Once you've done that, you will then square the numbers here. After you do that, you take the total, and then you put it into the formula. Remember, the whole of the top line of the formula is just this number here. So even though the formula may look confusing, it's actually quite simple. The top line here just becomes 68. And you divide that by how many numbers you have, take away 1. Well, you've got 5 numbers, take 1 away, you divide that by 4. And once you've done that, then take the square root. And that's how you find the standard deviation. Remember, the standard deviation is the measure of the spread of the data. If you get a low number, it means the values are fairly close to the mean overall. And if you get a higher standard deviation, it means the values are more spread out from the mean. So when it comes to the worded questions for standard deviation, which is here in this lesson 2, looking at comparisons, you want to compare the numbers. If it's a higher standard deviation, it means the results are more varied. If it's a lower number, it means the results are less varied, which it tells you right there once again. Looking at some of these examples, you had the mean running time of an Indiana Jones movie and a running time of the Star Wars movies. Because you can see the mean is lower for Indiana Jones, you could say that on average, because remember the mean shows you the average, you can say on average the running time is smaller for the Indiana Jones movies. And the standard deviation shows you that there's less variation in the length of the running times of the Indiana Jones movies, because the 6.3 is less than the 8. Remember though, when it comes to answering these questions, I would always say the mean shows that on average, because the mean is a type of average. And the standard deviation, when it comes to that, try to get in the word spread or variation and show that you know which numbers to look at. Show the examiner the numbers you are comparing. After that, we then went on to look at scatter graphs. Woo! What are scatter graphs? Well, scatter graphs are used to display two sets of variables to see if there is a link between them. If it is a positive correlation, that means that both values will be increasing. For example, as the outside temperature increases, more ice creams will be sold, so there is a link there. A negative correlation would be if one value increases while the other decreases. So as the outside temperature increases, well, a shop would sell fewer coats. So the number of coats sold would decrease as the temperature increases. And there is no correlation if you just get the points all scattered about, hence the name scatter graph. If there is no link between them, they are just spluttered all over the place. Spluttered? Is that a word? Once you've done that with National 5, a lot of the time you need to get the equation of a best fit line. Remember, it is just a straight line, so think back to the straight line chapter, and you worked out the equation of a straight line by thinking gradient, point, equation. For this example here, I gave you 2 points. It wasn't that obvious. I didn't tell you D is something something, but I did put it into the worded part of the question. So I told you it's a 2-month-old sheep that weighs 33 kilograms. So this point D would be 2, 33. Same with point E. I'm telling you that is a 14-month sheep weighing 129 kilograms. So really you can get both points. If you want the equation of the best fit line, you have to get the gradient, y2 take y1 over x2 take x1. You can then, once you've got y equals mx plus c and the gradient, sub the gradient and any point into the equation. If you subbed in the 2 and the 33, well, x was 2, y is 33, so you can sub them in and rearrange it to work out the value of c. Once you've done that, you know m, you've got c, so sub that back into y equals mx plus c. Just make sure you read the question. A lot of the time it doesn't want it in the form of y equals mx plus c. In other words, it doesn't want y and x. Why not? What does it want? Well, read the question. Here with this example, it wants it in terms of a and w. The x-axis is called a instead of x, which means the x was swapped with an a. For the y-axis, well, it's not called the y-axis, it's called w. So the y was swapped with a w. So just make sure you get it into that form. And if there's any part B, a lot of the time it will say using your equation. So just take your answer for part A and then sub in whatever you are told. Just watch for when they try to confuse you. Here they're telling you it's a 1-year-old sheep, but everything here in the question is in months. Ba-ba-ba-bam. So you have to put 1 year into months. Again, if you're wanting anything in more detail, look back to the individual lessons. That was just a quick recap. We then looked at some past paper exam questions, and the only one I wanted to highlight in this review lesson was this one. The reason I'm highlighting this one is with the best fit line, we're not told 2 points. So what we've got to do is we've got to look at where really these horizontal and vertical lines cross and try to pick off some points. So if you try to pick off a point, there is a point there. So that would be 1.5 and then 14. So that is a point. And then try to find another point on that line. You should hopefully see that the straight line is going through that point. So that would be 3.5 and then 8. That's the only difference. That's as tricky as this gets, just having to come up with your own points. But what I wouldn't do is start picking off the likes of this point here, where it's going to be 2.7, 2.8, 10. Don't start doing that because you'll be out slightly. Again, don't get the likes of this point or this point here, where you're going for 2, 12.5. Try to get points that it actually goes through, so you know you're going through at 2.4 or 3.8 or whatever. Hopefully that makes sense. Same idea though, once you've got your equation, a lot of the time just have a wee look, check if it wants it in terms of y and x, or this example was looking for it in terms of e and f. So you would have to write it in terms of e and f as it asks. And once you've done that again, a lot of the time it's a substitution question. This one here was telling you the engine size, or E, was 1.1, so you would just replace E with 1.1 in order to work out the value of f. Remember, this is a very quick recap. It is not me going over every example, and I did not go over anything in great detail there. It is just me going over all the key points. So anything that you get that you're unsure of, look back to the individual lessons. Look at 5.4 if you want more examples or more explanation with standard deviation. Look at 5.6 for scattergraphs and so on. If you feel you're okay with that though, maybe try some of these questions in the TJ National 5 book, or look at Zeta Maths, Lecky and Lecky, any book you like, whether it be online or a paper copy. And also past papers. Should be giving some of them a shot as well with the statistics questions. Good luck for the exam. See ya!